Hello friends, in this session we will be discussing about multiplexers and demultiplexers. A multiplexer is a combinational circuit that selects binary information from one of many input lines and directs it to a single output line. Here, this is very important. One of the many input lines and directed it to the single output line. The selection of a particular input line is controlled by a set of selection lines, also known as address lines. The n-bit selection lines can select one of the 2 raised to power n input lines. The block diagram of 4 to 1 mux is shown here. Here we are having 4 input lines I0, I1, I2, I3 and one output line Y, and we are having two select inputs S0 and S1. Depending upon the data on the select line, one out of these 4 input line is selected. The functional table of 4 to 1 mux is shown here. We are having two select lines S0 and S1. We are having one output line. When 00 is selected, the I0 will be selected at the output. When we are having S1 is 0 and S0 is 1, the I1 input is selected at the output. When it is 1 0, then I2 will be selected. When it is 1 1, then I3 will be selected. The logic diagram of 4 to 1 mux is shown here. It is very simple. We are having two select lines. We are having the inversion operation of these. If the input here is 0 0, then the inverse of this is 1 1. If this is 1, this is 1, then whatsoever will be here at I0, that will be transferred here and ultimately to the output. Similarly, if we are having S is 0 and S1 is 1, then this particular AND gate will be activated and output will be I1. Similarly, we will be having I2 and I3 at the output when the select lines select the proper combination of 1 0 and 1 1. Now we will be discussing how we can use multiplexer as a function generator. A multiplexer can be used in place of logic gates to implement logic expressions. Advantage of this: a single integrated circuit can perform the function of numerous logic circuits. It is very easy to change the implemented logic function if required. The various design steps are: make a truth table of the function to be implemented, connect logic 1 to each data input of the multiplexer for which the truth table output is equal to 1, connect logic 0 to the remaining data inputs, connect variables to the data select input of the multiplexer. We'll consider an example. Here we have to implement the function A exclusive or B exclusive or C. The first step is make the truth table. The truth table having the inputs A, B and C and the output F is given here. The output is high when the odd number of ones in the input are high. The second step is connect logic 1 for the input combinations for which the output is 1. Here we are having 8 to 1 mux since we are having 8 different combinations. So for the combination D1 we are having 1. For the combination D2, D4, D7 we are having output as 1. Now connect 1 to all these. Here we have connected one to D1, D2, D4 and D7. The next step is connect 0 logic to the remaining inputs. Now we are having the D2, D3, D5 and D6 which are the remaining inputs. Now connect 0 to all these remaining inputs. Then connect variables to the data select lines. Now the variables, input variables A, B and C, they are connected as the data select lines. A, B and C, they are connected as the select input lines. We are having the output F. In this way, the function A exclusive or B exclusive or C is implemented. If we are having A is 0, B is 0 and C is 1, then this particular line D1 will be selected. Since this is having output as 1, then 1 will be transferred at the output. In this way, with the help of these selection lines, we can select the different combinations and those combinations will be available at the output. Demultiplexer. A demultiplexer is opposite to that of the multiplexer. A demultiplexer is a circuit receives information on a single line and transmit this information on one of 2 raised to power n possible output lines, where n is the number of selection lines. The selection of a specific output line is controlled by the bit value of n selection lines. The decoder will operate as a demultiplexer when enable line acts as a data input line. We'll see here we are having the enable input which is acting as a data input line, and we are having the select line X, Y and Z. We are having the 8 outputs D0, D1, D2, D3, D4, D5, D6 and D7. When X is 0, Y is 0 and Z is 0, the line D0 is 1 and rest of the outputs they are 0, 0, 0. So the data which is available on the enable line, that will be transferred to the output line D0. Similarly, when X is 0, Y is 0 and Z is 1, the D1 output line will get activated and data on the enable line will be transferred to the D1 output line. This is the logic diagram of a decoder. Here the input lines of the decoder, we have made the select lines and we have added one more signal, enable signal, which is connected to each and every AND gate. Now when X is 0, Y is 0 and Z is 0, only this AND gate is active and the signal available on the enable input will be at the output of this gate. Similarly, when X is 1, Y is 1 and Z is 1, this particular AND gate is active. Now the data available on this enable line will be transferred as a output for this particular AND gate. In this way, we can send the data from one input line to the 2 raised to power n output lines, where n is the number of select lines. This lecture has been prepared from the book Fundamental of Digital Circuits by A. Anand Kumar, 3rd edition of Prentice Hall India Limited, New Delhi. That's all for today's discussion. Thank you.